All right. Quantum computing. You sent this video over from Polarify Consulting, and, well, it seems like you're ready to go deeper with this whole quantum thing. Beyond the hype, right?
And it's interesting you say that because there is a ton of hype around it, but there's also just a lot of confusion. People kind of lump quantum computing and AI together like they're the same thing. And I get it, there's some overlap, but as the video points out, they're pretty different.
Yeah, it's not like you can just swap one out for the other. So how do we even start to separate them? The video uses this analogy of brain for AI and like brawn for quantum computing.
Yeah, I thought that was a good way to put it. Because if AI is this brilliant chef coming up with all these amazing recipes, even the best chef needs an incredible kitchen to really make it happen. That's quantum computing the kitchen. It gives AI the power to come up with solutions faster and way more effectively than we could ever do on our own.
Okay, so it's not just about doing things faster, it's doing them differently. And this is where the video dives into qubits. They even had Quincy the qubit to help us visualize it. But mascots aside, what even is a qubit and why is it such a big deal compared to regular bits?
So this is where things get kind of wild a bit. Like in your phone or your computer, it's binary 0 or 1. Like a light switch, it's either on or off. But a qubit, get this, because of something called superposition, it can be both 0 and 1 at the same time.
Wait, hold on, at the same time? It's not like it's just switching back and forth super fast. It's really in both states at once.
Exactly. Think of a coin spinning in the air. Until it lands, it's both heads and tails at the same time, right? That's kind of the idea with the superposition.
So less like a light switch and more like, I don't know, a coin that's both heads and tails until the exact moment you look at it. Like Schrodinger's cat, but with computer parts.
You got it. Until we measure the qubit, it's like we're peeking at that cat. It exists in this strange in-between state. And that, believe it or not, is what gives quantum computers this crazy potential.
Okay, that's why, but it doesn't even stop there, does it? The video mentions entanglement too, and that sounds even weirder than superposition, if you can believe it.
Yeah, entanglement. Even Einstein called it spooky action at a distance. And honestly, it kind of is. Basically, you can link two qubits, and no matter how far apart they are, they'll influence each other instantly. Like two dice that always roll the same number, even if one's here and the other's like on the moon.
Okay, now we're just messing with the very fabric of reality, aren't we? So we've got these almost mystical sounding qubits, but how do they actually do anything in the real world?
That's the million-dollar question, and honestly, it's still early days for quantum computing.
Oh.
But the potential, it's huge. Imagine if drug discovery, which can take years now, could be done in days, just from being able to run simulations on a quantum computer.
Drug discovery in days. Okay, now that is some serious sci-fi stuff. But that's not all, right? The video mentions some other amazing possibilities too, like revolutionizing finance, even tackling climate change.
Right. I mean, let's think about finance for a second. Imagine being able to run these super complex financial models, risk assessments, and having the results instantly. Instead of just looking at past data and using regular algorithms, quantum computing could look at, like, countless possibilities at the same time. We could get a much clearer understanding of how the markets really behave.
So are we talking about predicting market crashes? Is that even possible?
Well, it's still early to say for sure, but that kind of gets at the potential power quantum computing could have. We're talking about optimizing trading strategies, managing risk in ways we can't even imagine right now, and yeah, maybe even getting better at predicting market shifts.
Okay, so maybe not quite a crystal ball, but definitely a powerful new tool. But the video also talks about how quantum computers could completely change medicine too. What kind of impact are we talking about there?
This is where it gets really exciting. Imagine being able to simulate molecules at the atomic level. That means we could design new drugs and therapies with incredible precision. We could even potentially cure diseases that we think of as incurable now.
Wow, that's amazing. And it's not just about finding new cures, right? The video mentions something about personalized medicine too.
Exactly. With quantum computers, you could analyze a person's genetic makeup and actually design a treatment plan specifically for them. So instead of this one-size-fits-all approach, cancer treatments could be tailored to your unique genetic code. That's the kind of future we're looking at.
So we're talking about potentially solving some of the biggest challenges humanity faces. No wonder there's this whole global race to build these things. The video even mentioned that China's Zhuzheng computer might have already achieved quantum supremacy. What does that even mean?
Yeah, quantum supremacy. Basically, it means that Zhuzheng can do certain calculations that would take a normal supercomputer, the ones we think of as powerful now, thousands of years to complete, and you can do them in minutes, maybe even seconds. It's a massive leap forward.
Thousands of years down to seconds, that's insane. No wonder everyone is paying attention.
Yeah, and it's not just China. The US, the European Union, all the big tech companies like IBM and Google, everyone's pouring billions into quantum research. This isn't just about scientific bragging rights anymore, it's about economic and strategic dominance.
Okay, so huge potential benefits. But the video also talks about some risks, especially when it comes to security. The idea of quantum computers being able to break our current encryption methods is a little unsettling, to say the least. How worried should we be?
It's definitely something to think about. You see, a lot of our encryption relies on complex math problems that are difficult for traditional computers to solve. But for quantum computers, they're easy.
So, are we talking about a future where all our data is vulnerable? Bank accounts drained, national secrets spilled, the whole nine yards.
That's the big question. But here's the interesting part. Quantum mechanics doesn't just create problems, it also gives us potential solutions. Remember that, spooky action at a distance. The video talks about quantum cryptography, which would use those same quantum principles to create encryption that's theoretically unbreakable.
So it's like a shield made from the same stuff as the sword. But instead of mythical creatures, it's protecting our data from quantum-powered hackers.
Exactly. In theory, quantum key distribution, QKD, could let us send messages that are basically impossible to intercept. Of course, the question is, can we get these defenses in place before someone figures out how to use quantum computers for, well, less than noble purposes?
Sounds like we're in a race against time. But going beyond security for a second, the video hints at some even wilder possibilities. Things that seem straight out of Star Trek, like simulating black holes, maybe even figuring out the Big Bang. Is this stuff even remotely possible, or are we getting carried away here?
It's important to remember that these are very speculative applications. But the fact that we're even thinking about them says a lot about how ambitious quantum computing is. Like, if we could simulate a black hole, scientists could learn a lot more about how gravity works at the quantum level. Who knows, it might even get us closer to that elusive theory of everything physicists are always looking for.
It's pretty mind-blowing to think about. So we've covered a lot of ground here, from the very basics of quantum computing to its potential to change everything from medicine to our understanding of the universe. But the video also reminds us that it's not all going to be easy. There are some big challenges facing this technology.
Absolutely. As incredible as all this potential is, we're still in the very early stages. Building and controlling large-scale quantum computers is hard, really hard, and we've got a ways to go before we see them everywhere.
Right, like those qubits, they seem like they need a lot of attention.
You could say that. Remember decoherence, which we talked about earlier. That's one of the biggest challenges in quantum computing.
Right, like these qubits are the divas of the physics world, always threatening to fall apart.
Huh. In a way, yeah. Qubits are incredibly sensitive. Any little change in temperature, vibration, even stray radiation can cause them to lose their quantum state, and that's when things stop working.
So it's like trying to juggle soap bubbles in a hurricane. Not easy. And then on top of that, we have to actually build these quantum computers, which I'm guessing is no walk in the park.
It's a huge undertaking. We're talking about engineering on a whole new level, and the more qubits you have, the harder it gets to control them and keep them entangled. It's like
Yeah.
trying to conduct an orchestra where every musician is also a cat.
So quantum computing, incredibly powerful, could change the world, but also has a ton of challenges to overcome. Sounds like we're still in the very early stages of this quantum revolution.
We are, but that's what makes it so exciting. We're on the edge of something truly new and amazing.
It's like we've just glimpsed a whole new universe of possibilities and we're just starting to figure out how to explore it. So where to go from here?
That's the big question, isn't it? The future of quantum computing is still being written, but one thing's for sure. This technology has the potential to completely change how we understand reality, and that's something worth exploring.
It really is incredible. I mean, we've barely scratched the surface here, and I can already feel my brain doing backflips trying to wrap itself around all of this. But even with all the excitement, it's important to remember this is still early days, right? It's like we're looking at the Wright brothers' first plane and trying to imagine a future with, like, supersonic jets.
That's a great way to put it. And just like with those early days of flight, there are going to be some bumps along the way. We already talked about decoherence, which is a big one, but there are others too. Like building a quantum computer isn't just about, sticking a bunch of qubits together. It's about getting those qubits to actually work together.
Yeah.
And I mean, interact in a very specific, controlled way.
Which is surprisingly difficult. So like herding cats, but microscopic and with way higher stakes if it goes wrong. So how do we even start to deal with these challenges? The video mentioned there are different ways to build quantum computers, right?
Yeah, they did. Right now, there are a few different technologies that are being explored, and they all have their pros and cons. Like one of the most promising ones is superconducting qubits. It's what companies like Google and IBM are using.
Mm.
Basically, they use these tiny circuits, and they have to cool them down to incredibly low temperatures, like colder than outer space, just to get them to work.
Colder than outer space. Okay, now that is hardcore.
It is. But the payoff is that superconducting qubits are pretty stable, and we can control them pretty well. Another approach is trapped ions. And just like it sounds, it involves trapping ions, which are just atoms with an electric charge. They use electromagnetic fields to hold them in place. And then they can use lasers to manipulate the ions, to basically represent the qubits.
Okay, so instead of tiny circuits, we're talking about controlling atoms with lasers. This is next level sci-fi stuff, but I guess that's the whole point, right? We're talking about trying to control the quantum world, which, as we've kind of established, plays by a very different set of rules.
Exactly. And that's what makes all of this so fascinating. It's not just about building a faster computer. It's about completely rethinking how we even approach computing in the first place.
So we're on the edge of this, like, quantum era of technology. But with all this talk about the potential and the challenges, what's the timeline on all of this? When can we expect to see quantum computers actually doing things that impact our lives? Are we talking years, decades, centuries?
Yeah, it's really hard to say for sure. Some people think it could be decades before we see quantum computers being used everywhere, but some are more optimistic. They think we could see some big breakthroughs in the next decade or two, even.
So no need to run out and buy quantum computing stocks just yet.
Probably not, no. But that doesn't mean we shouldn't be paying attention. Things are moving really fast in this field, and the next few years are going to be really important for figuring out where all of this is headed.
So it's a race, but we don't know who's going to win, or even where the finish line is yet.
That's a good way to put it, yeah. And that's part of what makes it so exciting. There are so many possibilities.
Too many to even get our heads around, probably. But let's try to narrow it down a bit. The video mentions some potential applications, but I'm really curious to dig a bit deeper. What could a future powered by quantum computers actually look like?
Well, one area where they could have a huge impact is in material science. Imagine being able to create completely new materials, like super strong but extremely lightweight alloys. That could be used in aerospace. Or we could design incredibly efficient solar cells that could revolutionize the energy industry.
So instead of relying on trial and error or accidental discoveries, we could essentially design materials from scratch, like atom by atom.
Pretty much, yeah. With quantum computers, we could simulate how molecules and atoms behave with ridiculous accuracy. It would give us so much more control over material design, more than we could ever dream of right now.
That's incredible, honestly. What about other fields, though? We talked about finance and medicine, but I'm guessing there are tons of other areas where quantum computing could be a game changer.
Oh, absolutely. Like artificial intelligence, for example. Right now, AI is limited by how powerful our normal computers are. But with quantum computers, we could create AI that is way more powerful than anything we have today.
So we're talking about AI that can actually think like us, not just analyze data and make predictions.
That's the hope, yeah. And it's not just AI either. Quantum computing could lead to breakthroughs in cryptography, cybersecurity, even things like drug discovery.
It's like this one technology could hold the key to solving problems we haven't even thought of yet.
That's what's so exciting about it. And it's why we need to keep pushing the limits and exploring what's possible.
It's exciting, but also a little intimidating, right? To think we're on the verge of such a massive technological revolution.
It is. But I think it's important to approach it with a sense of wonder. This is an opportunity to change the world for the better. And opportunities like this, they don't come around very often.
You're right, they don't. But even with all the potential benefits, we do have to be careful, don't we? Like they say, with great power comes great responsibility.
Absolutely. And that's something we'll talk about more in the next part of our deep dive.
It really is a lot to think about. I mean, on the one hand, the possibilities are pretty much endless. But like you said, we got to be aware of the downsides, too. It feels like every time we have some kind of big technological advancement, we open up these whole new ways for things to go wrong. And not always in ways we could have even imagined.
It's true. And with something as powerful as quantum computing could be, the stakes are even higher. Like we talked about before, quantum computers have the potential to break our current encryption methods, which would be a huge deal. Cybersecurity, privacy, even national security. It would impact everything.
Yeah, it's not just some kid in their basement trying to steal your credit card info anymore. We're talking about the possibility of, like, global scale disruption, even espionage, on a level we've never seen before.
Exactly. And that's why it's so important to be having these conversations now, before it's too late. While quantum computing is still relatively new, we have a chance to get ahead of these problems, to figure out ways to deal with them before they become unmanageable.
So we're trying to build the guardrails while the train's still being assembled.
Pretty much, yeah. It's definitely not easy. But the good news is that there are already people working on it. We talked a bit about quantum cryptography earlier, which could be a way to protect data, even if someone has a quantum computer. But there are other options too, like developing completely new types of encryption that are resistant to quantum attacks.
So it's like a tech arms race. The bad guys are trying to weaponize quantum computing, and we're trying to stay one step ahead.
In a way, yeah, I guess you could say that. But it's not just about being one step ahead either. It's about making sure this technology is used for good, that it benefits everyone, not just a select few.
It's easy to get lost in all the technical stuff and forget about the bigger picture sometimes.
Right, exactly. At the end of the day, technology is just a tool. It's up to us to decide what we use it for.
And that brings us back to something we've been talking about this whole time: the importance of understanding what quantum computing is, how it works.
If more people understand the potential, both good and bad, we'll be in a much better position to deal with the consequences.
It's like they say, knowledge is power.
It really is.
And in this case, knowledge about quantum computing could be the key to unlocking a brighter future.
I like that.
So, to kind of wrap things up here, I think it's safe to say quantum computing is one of the most incredible, potentially world-changing technologies out there. It's full of promise, but it also comes with its fair share of challenges.
Absolutely.
And like we've been saying, it's up to us to make sure we use it responsibly, that we use it ethically, and that we use it to make the world a better place.
Couldn't have said it better myself.
It's been a fascinating deep dive.
It really has.
And to everyone listening, we've really just scratched the surface here. Quantum computing is complex, it's changing all the time, and there's still so much we don't know. But hopefully, this has given you a basic understanding of what it is and why it matters. And if you're as interested in this as we are, don't let the conversation end here. Check out the links in our show notes, do some more research on your own, and who knows, maybe we'll be back for another deep dive on quantum computing sometime soon. Until then, stay curious.